So I don't see anyone on remotely, so people might pop on later, but it is being recorded and we will send out the link. So, and let's see, why don't I give it to you?
Okay. Kick things off. So welcome, everybody. Promises to be an interesting night tonight. Do I need this?
Might work if you're extremely lucky.
It vibrated. Maybe it woke us.
Okay, now it should work if you press that button.
Yay. Okay, so tonight's agenda is basically Starlink, a bit from Neil on how to set up.
I'm going to suggest we do Starlink after Andy's talk.
We're going to do Starlink later. So don't leave early. And so the main event is Andy. And so that promises to be a great presentation on antennas anywhere from 160 meters to 70 centimeters. So all is good. And Sam might chime in with some extra information as well. Oh, come on, you can do it.
It beats you.
It does.
Okay, why don't
So what do I need to do? Press the
space or the trackpad?
Yeah, space wasn't working either. Okay, reminders, no meeting in November. Next up is our last meeting of the year, which is the ham bake, which is tentatively on Saturday, the 7th, might move again, but that's what we're aiming for. It is a new date, so put that on your calendars. I'm hoping everyone can make it. Prasanna's and I and Mira are working on it. I will be publishing a Google spreadsheet where you can RSVP, number one, and number two, you can indicate what are the potluck you're going to bring, what dish or beverage, and also if you can help set up or tear down. And so look for that. I'll put out an email to the group. And something new, PacificCon was last week and it was a terrific meeting. Oh, Neil.
And you have the potluck?
I have to, it's either going to be
So not
here
yet.
or not yet, either
Okay.
here or the council chambers. Do you know who I need to talk to about calendar, or do you have access? Or do you have
I
access
think
to?
it's going to be the clerk who you've already been dealing
Yeah.
with.
Okay, so I can just ping her. All right, good.
Yeah, Karen is probably the first person I hit, and then Cody. I'll give you names and emails.
Yeah, okay. All right, so yeah, I'll chase that down and that'll be settled with the spreadsheet. But PacificCon was a great event and that was my first time there. So I learned a lot. And I'm looking forward to next year. But I've asked PK and Prasanna to give an update on kind of the events that they witnessed, and I'll chime in on some other stuff too. Go for it.
Okay, you want me to do it?
Sure.
Oh, okay. So,
Actually, let me give you the mic so that.
okay.
Wonder where my pen went.
Yeah, so there was actually, PacificCon actually formally began on the 19th. But on 18th, there is something called an antenna seminar that they have, which we attended. Now, there are 4 of us from this area. Of course, we met Bill over there. I had W4 NJK Charlie, KN6OZ Galen, and KO6 BWE Prasanna, and yours truly. We all, carpool together on Friday morning, early morning at 6 o'clock. We got there around 8 o'clock and it all started on time. And the antenna workshop was terrific. And it was mostly, a big chunk of it was for wire antennas. And I especially liked one where they talked about the NFET or the ZEP antenna. It's interesting that it was used on the Zeppelin originally, pre-World War II. And they also talked about MIMO antennas for shortwave, which was a new idea. And then they also talked about a new type of circular polarization antenna, which is also very interesting. And on the 19th, I attended 2 talks on Arden. There was a fantastic amount of interest in Arden. The session was packed, a lot of questions. And afterwards, I had a chance to chat with W6BI out of Southern California, and I talked to him about hardware, and he has promised to help. All you got to do is just send him an email, and he'll do this. That's what he said. And the second interesting presentation I attended was by Jim WU0I out of Honeyville, talked about AMSAT, satellite operations. And our high school students here locally might be interested. That might be a way to get them hooked into amateur radio. And the third item was the Scout Radio Merit Batch. They had a big session going on, like 35, 40 scouts were there. And so one of the things they had to do was to attend the lecture and fill out a little questionnaire and then go make contacts. There's jamboree on the air going on. So they got on the air and made a few contacts. And during lunchtime, there is something called parachute mobiles. People were jumping out of parachutes. And if you made contact with them, all you got to do is say announce your call sign. And they announce it, and they promise to send a QSL card to everybody. So I did one, Charlie did one, Galen did one. Prasanna did one, but she's not sure she got a call sign through or not. That is fun. And then there is a very good presentation by Dave, KE0OG. He's on YouTube on wire antennas, and also another talk about ballooning. So there are a bunch of vendor booths too. We couldn't stay for Sunday. Bill told me that there are some sessions were going on in repeater design and in whatnot. So I have a program here, and anybody's interested, let me know, and I'll be happy to share this. Overall, great conference.
It was great. And as a newbie, I learned not to be so cavalier with antennas. My HT, I didn't really pay any attention to it, but when you run a bigger wattage, you can have like 5,000 volts at the end of the wire. and it could be 5,000 volts up in the air, or it could be on the line on the ground. So that was news to me. On the Arden front, I did also connect with a guy in San Bruno, or I have to track him down, but he is working on Arden for a mobile environment. So he's supposedly tweaking software, and there's some new 900 megahertz 802.11 AH. So 802.11 AH is a new 900 megahertz radio, I guess, protocol. And so they're looking at Arden, I think, for that. And then also I went to a WinLink presentation. And while Santa Clara County doesn't use WinLink, it's packet-based. A lot of other places do. I spoke to a guy in Walnut Creek who oversees their CERT group, and they've actually implemented receiver voting for their repeater so that they can have better coverage with basically the same frequency. And then also they use WinLink to send messages, attach photos and things like that from the field into their CERT group. WinLink is set up to use the cloud, and it's designed for HF communications for across the country or wherever. But you can operate, at least they said you could operate WinLink without a cloud connection. It could just be a local thing. And so I'm wondering if that might be a way forward for the CERT group to send pictures along with incident reports, because all the forms are clicked down. Or you can just click and get a form like a 309 or whatever, fill that out. So I think there's some things to explore there. So it was a very good conference from my perspective, from learning a lot of new things. And Prasanna went to,
Oh, my highlight was meeting God in West. And I got inspiration to do my general licensing, so I'm gonna take that. And I walked around and I met a group, and it was a young radio club, young ladies radio club. These are all young ladies, they're all gray haired like me. There are a few young ones, but it was so inspiring. They do so many fun things. They also did most recently what is called Route 66. It's like the Porta and Sota. So she inspired her team, this lady who presented. She's from San Bernardino area. She's the organizational head for the entire California, the District 6. She inspired the team to get 6,000 contacts, and they got it. So,
pretty amazing.
and I joined the group. I think they're very inspiring. That was the exciting part of my thing, meeting Gordon West and getting to know about the young ladies radio league.
Cool. Thanks, Prasanna, and thanks, PK. So with that, let us attempt to skip over Neil and go to Andy Kirk.
Well, can you throw up the file that I've got?
Yeah.
Good. Just don't put on any of the music.
So basically you can just click through and all your slides.
Oh, here we
everything will be
go.
there.
Yeah. Well, I thought I'd throw this in first. This is I imagine somebody might want a copy of this. This is the bands and the distances that you're going to be cutting antennas to. Now, the reason that some of these have been left out is it's just not quite worth it. Nobody is going to put a 5/8 wavelength on 160. I did put a half wavelength once, but it was so close to the ground that the radiation went up and down. They covered the local area very nicely. And actually, there's an article at QST about using 160 or 80. 75 is really 80. In case of an emergency, to get a hold of Sacramento, because it will be a short distance hop that will work. Also, they're talking about 40. The antennas will have to be close to the ground. Now, it's just an aside there. Let's see, can I bring, how do I, okay, I just did. How do I go backwards? I'm going back,
Stop clicking. Yeah, stop clicking. Stop thinking.
okay. What I would like to do, okay, I did get the
Take the
back.
hit the back arrow right there.
Okay, the back arrow. Yeah, well, so these are the distances here for the UHF and VHF, 70 centimeters. Now, I have built antennas for all of these bands. And this is a half wavelength at 70 centimeters. And as you probably know, we get antennas and handhelds that are longer than that. Both very easy, that wire at the base of the antenna. It's not just big enough for the connector. That wire is also there to allow you to work on 70 and 2 meters at the same time. I think most of you have 2 meter 70 centimeter hand meters. This is the quarter wavelength, of course. Now this distance is, why did I put a 5/8 wavelength there? This distance is something like 3/10 of 3.3 wavelengths. I'm not sure why I bothered with it. There is a distance there, a use for it. Did I really complete this?
Well,
Anyway,
I may have
I'm gonna
missed-
go to the next one.
I may have missed some things in the transcription, but
Uh-huh.
I don't think so.
Okay, now my favorite 2 meter and up antenna is a double extended ZEP. A double extended ZEP is well, a single ZEP extended is 5/8 wavelength. That is the best you can do with one antenna. You go beyond that, and the signal starts going up the length of the antenna. For a vertical, that's not too good. He wants to spread out horizontally. So stay with the 5/8 wavelength. Double extended depths gives you two 5/8 wavelength antennas. And this is a schematic for it, for 2 meters. That's a 5/8 on top, a 5/8 on the bottom. I've got a photograph of one coming up. It's fed with open feed line. Now, it's hard to get, so you make it yourself. 14 gauge bare wire. You make it half a wavelength long. But you run a shorting stub here. What this does is because a 5/8 wavelength is a very high impedance. The end of that feed line is a quarter wavelength, or was a quarter wavelength, you shortened it. It works like a tuned circuit. And you're tapping it part way up with coax. I use coax, but you could use a ballon or Ullin or something. I used a 4-to-1 ballon with 50 ohm line, and it wound up, instead of being down here on my 2 meter antenna, on my 440, it wound up way up here. That's because a 4-to-1 ballon will transform your the impedance of the feed line up to a higher value, which is sometimes very necessary. Remember that a 48-inch on 2 meters is 5/8 of a wavelength, and it's got a very high impedance. By the way, that 48 wave, it works as a quarter wave on 6 meters, but I wouldn't try driving it. Now, let's see. Okay, that's the next antenna coming up. Yeah. This is a picture of the end of my big stick. That is the 40-meter antenna. Okay. And that's how I held it together. That antenna consists of 16-foot 2x3 piece of wood, stiffening the aluminum tubing. And that's how the tubing is held onto the wood, first of all with a hose clamp. And then I wrap the electrician's tape around there. It's really to keep the halyard from hanging up. You can see that part of that is a rope. I call it a halyard, which I use to raise the wire antenna for 160 and 80. That's the top of it. Actually, there's another 3 feet beyond that you can't see, which is 6 gauge bare copper. Now here's the antenna that I am using for both for 10, 15, and 20 meters. I am using a fan inverted V. I have tried fan dipoles. They're okay, but they don't match well. An inverted V, the antenna has one support, which saves you an extra support. It doesn't take as much space because the wires come down. The wires are a quarter wavelength long. So it's effectively 3 dipoles fed by one feed line. It saves on feed lines. And believe me, at one time I had 4 or 5 cables going across from my shack to the base of where all the antennas were. That is called an antenna farm. The copper wire that you see is just for strain relief. Because this guy here is broken a couple of times. I admit that's an ugly looking antenna, but it works. Especially on 20. This is the same idea, but this happens to be a picture of the same thing. But it's a 15, the 17-meter and 24-meter antenna. Once again, a fan inverted V.
And sorry, it's a fan because they're just multiple, you have multiple antennas coming to a common point.
Yeah, well, no, yeah, that's right. That's why it's a fan. An inverted V also supposedly, this is what I read, I'm working on it. It's easier to match. Remember that a straight dipole has about 70 ohms impedance. Your feed line is 50 ohms. You are going to get a 1 to 1.5 to 1 mismatch. But by playing with the height of the end of the wire and the length of it, you're supposed to be able to bring it into resonance so it actually feeds at 50 ohms. Now here's a ground plane. That one they have designed for both. They've got the list there for 2 meters, 220, and 70 centimeters. Ignore that wire, that line at the top. I didn't notice it was there when I took the picture. It's a really simple setup. This is a UHF panel connector, female. You connect the radials to the panel, to the flange. You connect the upright radiating element to the center portion of it. And I brought in a couple of samples of those. Here's a photograph of the finished product there from the ARRL handbook. The ground plane antenna like that has been described as a semi-radiating dummy lobe. It's got a ball-shaped radiation pattern, which is not too efficient. It'll work, it works, but there are better panels made by longer antennas, which we'll get to. You only need about 4 radial wires if you've got the antenna up in the air. If you're putting it on the ground, I may as well talk about ground radials. You're going to have the antenna based on the ground, which, like any normal HF antenna, is going to wind up. You better have a lot more copper there. It's okay to bury it. 2 inches is good. I rototilled the area before I put it in. But they say, well, the broadcast people say 120 radials, quarter wavelength long. At 160, that's a whole lot of wire and a lot of work. I have, for all the bands I'm working, I have about 35 radials buried, and they're each about 30 feet long. For 40 meters, it's wonderful. For 80 meters, so-so. For 160, yeah, not so good. But that's what I got. There, I was talking about the double extended ZEP. There it is. That's made out of 6-gauge bare copper wire. It would work a lot nicer if I made out a 1/2-inch ID copper pipe. And I have made about that.
Why is that?
What?
Why is that? Why would it work better out of?
Okay, the wider your radiator, the more bandwidth you will have in the antenna. Therefore, if you QSY off one frequency, you can go further before the voltage standing wave ratio starts to climb up and your signal drops off. You will lose a signal, the power in the antenna, in the feed line. And, well, I may as well talk about VISWAR now. Voltage standing wave ratio is voltage that has jumped up on the feed line and goes down as a sine wave. You don't really want that. First of all, it returns the power back to the transmitter. It bounces back. They call it return loss. And you want forward power and you don't want any reverse power. It used to be possible to burn out the final of your transmitter if you had too much of it. The voltage would get too high at the transistors of the solid state devices. Most transmitters nowadays have a fallback circuit, so if it senses a high VISWAR, it shuts down or reduces the power. I used to work on those at microwave frequencies. Anyway, this is a wooden support here, two wooden supports out there to hold the wire. This supports the feed line. I mentioned it's, you make it yourself, it's open feed line. It cannot be more than 1/10 of a wavelength apart. Better, much closer. You slide the shorting stub and then the attachment, the coax, you slide that up and down, looking at your power meter until you find you have the least amount of return and the most forward power that you can get. Keep that away from metal and away from the ground. When I set that thing up originally, it was down at ground level. And unfortunately, it doesn't quite work as well at my usual frequency, which is N6 NFI, which is transmit frequency is 1.5, receive frequency is 145.230. Transmit frequency is 600 kc below that. So it's on a post on the roof of my house, and I'm not permitted to climb up there anymore because of my balance. So I got my son to straighten it. There's another view of it. I hope to get a good picture of it close up.
I guess question is, I'm only capturing some of what you're saying, so the one thing I did capture was, is it always true that a pipe shape of the radiating portion of the antenna would be better than just a bare wire?
That's right. Well, basically what to get you is that you can shift the frequency away from a center that it's designed for a lot further. Like I say, I did make them once out of a copper pipe.
And this radiation pattern for the double ZEP is omnidirectional.
It's omnidirectional, very omnidirectional. And it's 8 dB gain off of a ground plate antenna.
So when is that the one you use for the Monday Night Net?
Well, I have a 70 centimeter type like that, which I try to check in. And since I've not been too successful with 70 centimeters on the Monday Night Net, I check in on the UHF net with, I've got a 440. But I've been lately checking in on 220. I have a handheld for 220. I have a portable for 70 centimeters, also works sideband. I had tried to get these set up right, but where I wanted them. Okay. This is for my, let me see, that one was for my 20 meter vertical. I had a 5/8 wavelength, 20 meter vertical. which is 41 feet high. Base loaded, base fed. It's voltage fed. Now, a ground plane, like I've shown you, is current fed. The high current is at the bottom, and that's where the radiation comes from. But I voltage feed the 20-meter 5/8 wavelength. This way I get a little bit more gain using a full 5/8 wavelength antenna, about at least one S unit, maybe two S units better. But I've had to make a matching network to take the 50 ohm output of my transmitter and boost it up to the input impedance of the 5/8 wavelength. It's a high impedance, not a low impedance. And that is a matching network. It's pretty much like what you have in a matchbox or an antenna match thing, except I was going to get the whiteboard news out here.
It's gotta go. The clean side is.
Am I hitting anybody in the nose? Okay.
No markers. I'll be back.
Oh, okay. Anyway, this is what we call a tank circuit. It doesn't come from tanks, it comes from a water tank that you fill up. This thing soaks up the juice and puts it out. It's a great way to build up a high voltage. It's a transformer, but it's a tuned transformer. This wire here comes from the coax, and I want to solder it. And it's a step-up transformer. The voltage steps up by the ratio of these turns, which is what 3 turns, and it gets up to the high point. You can get a pretty high voltage out of one of those, but there's no need to do it here. We're matching, I think you're matching something like 200 ohms on the base, at the base of a 5/8 wavelength. It's also got a little operator J, we call it. In other words, it's not a pure impedance, not a pure resistance, it's an impedance. There's an X factor in there, the square root of -1. So you're also matching that out when you use that. You just feel around until you get a good match. You keep tuning the capacitor. And as you can tell, that's PVC pipe that I'm using for the base of the end, for the coil form. And I'm not sure where I got that capacitor, but you'll notice those are wide spaced. Thank you. Those are wide space plates. That is a high voltage capacitor. That is not a receiving capacitor. Now, where was I? Yeah, let's take a J antenna. This is a pretty good antenna for mobile use. This is about half a wavelength. Sorry. Thank you. I think that's a symbol for half wavelength. And the coax comes in here, attaches here for the center, and usually here for the shield braid. This is also a tag circuit. It's an open feed line, shorted at the bottom, open at the top. You're energizing it with the RF. So basically, you've got 0 ohms here. 50 here. And 200, maybe 250 here. Halfway minus something J. It's an imaginary number. You've taken any algebra, you know what there are imaginary numbers. This is exactly identical to this. Coax antenna. I know, you notice there's no capacitor here. It's capacitive. All right. Now, I've got made up 2 of these boxes here. They're a little overkill because the antennas that I have built are long enough so that they've got a full bandwidth over the band you want to use. Supposedly, well, that worked for the entire 20-meter band, which is 14.0 to 14.35 megahertz. I aim it a little higher than the center because I don't use CW anymore. Let's see. That is how I drive the capacitor that you've seen. That's called a velvet vernier dial. It used to be made by National Radio, which went out of business about 40 years ago. I got that and another one off eBay. You can get them for about 12, 15 bucks. Well, that was 10 years ago. It may be more now. It's a 5-to-1 indexed to 1,000 particles. You see the 100 up here, and you've got a vernier scale here so you can divide them up. That is a little, once again, it's a bit overkill, but I got them. I like to use them. The box that is in is what the electricians will call an in-use box. That's it. Usually you'll find this outside the house with a switch or a electrical receptacle on it for power. Yeah, you get them at Home Depot. And this is another view. Okay, now we come to my favorite antenna. This is the antenna I'm using for 160. For 160, 80, and 40. This is a good antenna, but it uses a lot of space. I've shown you how I make a pole. Okay. I have a pole. We've got a swivel base because I've had to take it down about 5 times in the last 15 years. This is a combination of a 2x3 clamped to a 2x2 from Southern Lumber, which isn't there anymore, and an alloy aluminum tube, different sizes going all the way down to the base. And then there's a little copper on the top, which happens to be bent over. I hit a tree, or hit a tree. Down here, we have the buried radials that I mentioned. We have a whole lot of them because it is necessary. Then I have a pulley about here, and I have 2 wires coming up here. They are separated at the base. They come more or less together here, and then they go off. On 60, and 80. The 160, I looked up the records, it's about 155 feet. All the way. And this guy is around 80 feet. From one end to the other, from the bottom up here. They are longer than a quarter wavelength. Why? Well, I mentioned the dipoles are 75 or 70 ohms. A vertical, quarter wavelength vertical is 39 ohms. Once again, it's not quite the right match. Somebody once asked if 50 ohms, they made 50 ohm cable as a compromise. That's really not the answer. They became 50 ohms because the manufacturers found it a lot easier. They had the facilities already to make that up. Now, at the base of this antenna, the reason I do it longer than a quarter wavelength is that this way I can get 50 ohms, but I'm gonna have this guy. This matches the coax here to the base of the antenna. There are 4 screws on the top, and these wires go to them. The 4th one is just a spare. Okay. I was given this. This is for 160. Notice the spacing? I think I bought this years ago, a place up in San Francisco. This has got a velvet vernier drive to it, another one. So I can set it exactly. And this one is knob on the end, I think. I got this in a surplus place, and I think it was a tuning knob for a BC 610 transceiver. Does that ring a bell? Yeah. A BC 610 is a surplus, very surplus military transmitter. I think it stood this high. Anyway, so I have 4 capacitors in here. One of them is a adder that goes alongside the 160 to add a little extra. The other one is for the 40-meter antenna. I found that I could tune across the entire 40-meter band without Viswar climbing up above about 1.5 to 1, which is acceptable. That's at the bottom, which I don't use. It was better at the top. And I can set the other 2 pretty close to 1 to 1, which is perfect.
So in your shack, then you have an antenna switch.
I have an antenna switch in my shack, but this takes a single wire, single antenna feed. Yeah,
Yeah,
like the fan dipoles.
and then do you connect your SWR meter here?
Okay, I have 3 SWR meters in series in the shack. They're all for that one feed line. Now, no, one of them is for the others. My transceiver has 2 SWR meters in it. One's digital, one's analog. And then I have a 3rd one in the feed line, which is a nice big analog one I got from MFJ. No, I take that back. I got it from eBay. And that is a 3,000 watt unit. The meter. I'm not running 3,000 watts. Let me see.
So you have to have somebody out here.
That is at the, well, look,
Tuning the dials while you're inside.
Yeah.
watching meters.
I can watch the meters. I don't have, well, let's go back one. Oh. There. That's the dial. I sat down with a graph, checked it every 50 kilohertz, wrote down the numbers, went back, and put it on a piece of graph paper. And the curve, well, the curve is pretty close to a straight line, but not quite. So here I have the numbers for the frequency. Here I've got the numbers, and here's where I set it. So I could set it, and then I run down there with a flashlight. And an umbrella. Hoping I don't wake anybody up, but it's sometime at dawn and Godwin time in the morning. And send to that number and come right back. Which makes changing things right with a power meter at the base of the antenna. Right now, there is a power meter at the base of the antenna because I gotta do some recalibration. I find calibration is good until it rains. Then you find some changes. If it's changed, the curve itself doesn't change. It just moves to the left or the right. So you get, well, it was 10 units. It's still going to be 10 units. Crank it down. And it generally comes right in.
Is that the coupling of the radials?
I'm not entirely sure. Because sloper antennas also change in the weather. And this is that's the box. This is one of them. There's another view of the matching network. There's the front. And you see I've got the in-use cover on there. And that extra coax receptacle at the bottom was another project that didn't work out. I've left it there. This is the one I've got on 15 meters. I was working on it this morning. This one's a little bit different. For example, I've got a clip weight here to adjust it, which is fortunate because this thing is now off. I moved it. The screw here and the screw here are designed so that once I have that set, I can rotate that coil and change the position of the clamp of the alligator clip to readjust it when I have to readjust for a different visual. And the knob here is let's see if I've got a picture of it. Yeah. That is a Vernier 5-to-1. I think I picked up at a surplus store that's not there anymore. It was up in Redwood City. And you just once you get the thing properly adjusted, you can change the frequency that you're working at. Actually, once again, this is overkill. If I get it set for 15 meters, I don't really need, actually don't need the dial, and I don't need a variable capacitor. But it's what I'm using right now. Oh, here's a picture of my J antenna, a J antenna. Like I say, a half wavelength, quarter wavelength there, and it looks like a tuned circuit, a tapped coil, a tag circuit. Well, that's about it. I find that my inverted L's, I've been using them almost every day. Oh, there's a good question you might ask. With a inverted L, like I showed you over there, does it make a difference the height at the end of the wire. And I've had mixed results. Lately, I find it does make a difference. In fact, as I readjusted, it's one time when it got wet by just changing the length, the height of the end of the antenna. By the way, the 160-meter wire is about yay far from the ground in the middle of that thing. One word about inverted L's or any kind of antenna. Which you mentioned. Yes, the end of that antenna gets hot. I'm using insulated wire for the inverted L's. And I found spots where the insulation has burned off from high voltage. And I talked to one guy on 2 meters about a week or so ago, and he told me he set fire to a palm tree with the antenna. You can get a hell of a jolt out of the far end of an antenna. Oh, now I think I ought to talk about loaded antennas here. I don't have an illustration, but you don't have enough land to put up an inverted L. Well, you put this guy here. And then the easiest option and the cheapest option is to put a coil here. Now, that takes away from your radiating spot. So, a better idea, and you'll see this in a lot of mobile, HM mobile antennas. Oh, here's your feed line. You put the coil up here. This end is a high current end. That's where your radiation actually comes in. This is well, it's a high voltage here. It's not that much current. There's not a lot of current here. This end is a sensitive end. You keep adjusting this length to get the whole works to match, because it's all solid here. If you've ever used an HF mobile antenna, that's how they do it. There's a big loop, a big coil here, usually encased in plastic. Then the adjustable thing, you slide the top wire in and out to set up the coil. You can set it up for portions of the band. You can set it up for the top of the band, for the bottom of the band. For 80 meters, you have to have 2 different antenna coils. Because 80 meters, the bottom of 80 meters is Morse code only, CW. That's the first 100 kc. And you cannot make the 80-meter resonator work down at the bottom of that band. I tried. Another thing, shorter the antenna is, using the coil, and you can do it on a straight vertical at home. You can do it on a dipole, as a matter of fact. It's not hard to do it on a dipole, except that the weight is going to be a problem. But the shorter you make the antenna, the less bandwidth you're going to have. And bandwidth is where you can move off of the center, off of a frequency, move it up or down a couple of 100 kc or 75 kc and kilohertz, excuse me. I'm showing my my age here. And once you move it past that, the voltage standing wave rate starts to go up. I had a chart there that showed a separate chart that showed where the voltage standing wave ratio was coming up. Center frequency, 75 kc here, kilohertz here, and 75 kilohertz here. here's a little item though, it has nothing to do with that. If you're working with abbreviations, like megahertz, how come the center is capitalized? That's not capitalized, that's capitalized, that's not capitalized. The reason is that hertz is a man's name. If you have a unit that a guy developed, like his name is on, Farad, Frenchman. Hertz, watts. The abbreviation for his name is always capitalized, even if it's in the middle of the thing. I learned that when I was working at NASA. Oh. There's a list of things I'm going to talk about if I had the chance. Yeah. Line loss. There is a RF cable called RG7, RG175, I think. I've used it. The only use I can find for it is replacing a shoelace if you've broken a shoelace. It's also small. It'd be great for DC, but for RF, not so good. RG58, 50 ohm line. You see a lot of it around. It's got a line loss. 100 feet of it, they list it. I don't have the numbers, but it loses a lot. But a short run, it's fine, even for a kilowatt. RG8 is a good cable. RG215 is also a good cable. It's better. It's 0.4 inches in diameter, whereas your RG58 and RG59 are 1/4 of an inch. By the way, RG59 and RG9 are not 50 ohms. They're 75 ohms. They're for TV distribution. And I was going to bring in some samples of connectors. I got them. Let me go around here. My jacket pocket.
Yeah.
If you're not familiar with these connectors, you might want to look at them. Yeah. Okay. I've got 3 types of connectors here. This is a so-called UHF connector. For those of you who have never worked with an HF receiver or transceiver, this is what you're most likely to be using. You want to pass it around? That's got a female connector on one end and a male on the other. This, I've only got a male connector here. 2 males go down. That is an N-type connector. It is weatherproof. UHF connectors are not weatherproof or waterproof. Now, this is a BNC. The question came up, where did they get the initials for this? The rumor is that they're initials of the guy who designed it. No, I think it means threaded naval connector. Or rather, bayonet naval connector. There's also a threaded naval connector. That is 50 ohms, guaranteed. UHF is not necessarily 50 ohms. It's something they came up with. We got to connect these cables. So they made it. It's close to 50 ohms, okay? And here's these guys. are SMA, there's a male and female here. The other end is a BNC, there's an
Right.
adapter. They go together. You can't, the recommendation is don't do that, don't take it apart too often. That is what they're using these days on handheld radios. I used to use BNC. But now they use the SMA connector. And I had heard, somebody said you could just disassemble them and put them back together about 500 times before they wear out. I got a hunch it's not quite that much. I avoid removing the antennas from my handheld because of this reason. Or I don't do it as much. One of the guys I know, Dr. Kozak, KR60D. He tells me that every one of those he puts in a BNC connector so it doesn't wear out. It's a good idea. That's one of the reasons I got those. So, something else to worry about. This is also a BNC connector, but unlike those, I believe this particular one is 75 ohms. So if you're down at a surplus store buying those things, be sure you get a 50 ohm one and not a 75 ohm one. Although I think that one is set up for our RG8 Mini, which is a miniature RG8, which is pretty good stuff, they tell me. Well, let's see if I've got anything else here. Nah, that's it. I thought I'd put these in order so they'd be more useful. And then, like I say, that's the front of it. It's got the same panel in front for the weather. But when it starts to rain, I wrap a garbage bag around both of those guys just to make sure.
Okay.
Yeah.
Any questions?
Thank you for doing the presentation.
You're welcome. And now it's a load off my mind. I can go and concentrate on the other things I need to concentrate on.
Before I switch to Starlink, anybody have any questions for Andy? Okay,
I think
You want me to say anything or?
up to you.
Offering to add some additional.
Yeah, let me just talk a little bit about, commercial grade antennas. I thought that everyone would be interested in how these are made. The way in the commercial radio field, there's been a lot of interest in gaining
You can
And-
use the spray on there. Sam.
yeah, it's not cooperating anyway. There's been a lot of interest in getting, gain, so that you can get more mobile range. And, they've developed, different kinds of antennas. The early ones, actually, were very interesting the way they did them, but let me just show you initially here what some of this might look like. If you have, an antenna, what you'd have is you'd have these dipoles or these base radials. And these are, Y/4. That's typically that's quarter wavelength. And what would you have here is just regular coax, typically RG8 or something like that. And then you'd have a radial element that's inside here that looks, and initially they made these out of pipe. And they'd get more bandwidth that way because diameter was bigger. Well, they found, we can make these things cheap. And what they found is that you could just take a piece of coax here and you hook up this part to the shield, and this center conductor gets hooked up here and goes up the middle. And then when you get to here, you put another one of these guys in here and you crisscross this. In other words, you take this center connector and go to the shield, and you take the shield and go to the center. And so you keep going like this. It turns out that the more of these you put in here, the more gain you can get. At UHF frequencies, a company called Phelps Dodge, it's gone away, built what was called a super station master antenna. And this thing would give you 10 dB of gain over a half wave dipole. Now, we haven't talked about references here, but typically antenna gain for these UHF antennas is measured over isotropic media, which is kind of like a quarter wave. In the commercial business, the gain is measured over a half wave antenna, a typical dipole, which is you get this, and this dipole here is typically about 3 dB a gain over a quarter wavelength, which is one of these little guys where you have, you see a little stick on top of a car or something. That's normally a quarter wavelength antenna on UHF and 2 meters and all of that. And so with this guy, so this would typically be 3 dB gain over one of these quarter wavelengths. Well, this antenna here, using these guys, and it's a large number of them, you get 10 dB a gain over a half wave dipole. And the reason is, the more of these you put in, the more the phasing you get between them, and the narrower the pattern goes. So what you get is initial pattern, is really wide. Well, when you start doing this pattern squishes out, and it makes a very narrow pattern. And that pattern is typically about 2 degrees between here and here. And so you have to have that really aligned properly. And if you're going to put in a repeater, you want to make sure that if you use a gain antenna on your repeater, that this pattern matches up with your users. And that means if your users are all close in, then you put down tilt on this, and you can put, several degrees down tilt. And typically you can order these with a certain amount of down tilt. They normally would come from the factory, with typically 4 or 5 degree down tilt, and you can make that higher if you need to have more. This is up on a mountaintop and your users are down below, you might want 10 degree down tilt on this pattern. But that pattern is really important. When I was putting in repeaters, I found that you had enough gain that you really wanted this pattern to be out at the maximum range. And so what I would do is I would make sure that I had really good receivers, really high transmitters and all of that. And I'd use one of these high gain antennas. And as I said, it's got many, many, many of these little sections. Each one of these sections is a quarter wavelength. So you could tune these, you could play games with them, you can do this stuff with them to get them to work exactly on your frequency, because these are typically made for various frequencies. These antennas were kind of expensive, costing about $450 when you bought them, and this was in the 1960s. Now, one of the things you could do is, if you were a ham, you could go to Phelps Dodge and they could sell you these things for $150. And that was a much better deal.
So look, that's just a collinear array.
This is called a collinear, that's correct. And, you can, but you can see these things for sale, typically a 6 dB stick, which is basically just a covering over this antenna, which is a fiberglass, woven fiberglass thing. Typically it's white colored. And what it's covering up are these little guys, and what they do, as I said, they just take typical sections of coax and separate them and cross-connect at each of these points. And that's all you need to do, and then you can drive this in the center and it feeds the whole antenna. And typically one of these things will give you about 6 dB a gain for a small one. And as I said, the Phelps Dodge ones it was 10 dB over a half-wave dipole, which means that it's about 13 dB with reference to the quarter wavelength like you'd find on your car or something like that. And so when you start putting this kind of gain in there, you get enormous ranges. And as an example, my repeater on I can get into it at Sea Ranch, which is 150 miles away. And this stuff really does work when you do that, but you need a really good transmitter, at least 50 watts, more like 100 is better. And you need a super good receiver with a preamp front end. And you have to specially tune everything because you need a duplexer on this, and you need a duplexer with about 120 dB of loss between the transmit and receive, which you can do. You can build them that way, but you have to tweak them. But when you get that much isolation between transmit and receive, you can get really good range. But there's a whole lot of places here where you can get sloppy and the coverage just goes down the tubes. So anyway, I wanted to pass on some of this about antennas because the art of building these is not as well known, but I've taken a lot of these apart and you can see how it's done. As I said, in the early versions of these when they started making this, they'd make these out of aluminum tubes. And you could take these things apart and tune each of these tubes to the frequency you want. And you had to do this kind of stuff because these things were made for the commercial band. If you wanted to use them in the ham band, you needed to make these guys longer. And you can do that when you take them apart. This kind is harder to do that with because it's very hard to make this stuff longer. You can sometimes make it shorter, but longer is another story. So anyway, I wanted to pass that on.
Thanks. One thing also I learned at Pacificon, I forget the guy's name, Tom Silver. Yeah, was that for your magnet on your car, if you just cover it with a copper braid, the length of it, you can get about 1.8 dB additional gain. So it's because stainless steel is such a poor radiator. That you're actually improving the efficiency of the antenna. It doesn't have to attach at the base, according to him. You just close the top off, and it's a sleeve. So it's not something you can use probably while you're driving, might blow off, but or you can fix it.
Well, that's interesting because you know that when they were started making these, they were more careful and they would make they would cover those steel things with a copper cladding, which because it's all skin effect in this with radio. Nothing goes through the center, it all goes on the edge. That's what happens when at these high frequencies.
Yeah.
So you can make it out of copper or even silver. And yeah, they work much better when you do that.
All right, back to play.
Okay, so if we could clear off this table, I'm gonna put the Starlink and stuff there and invite everyone to stand up and look at it.
That's the check. Yeah.
So I wrote up instructions, which we plan to put in the box. Not very many people have reviewed the instructions, so if you think it could be clearer or parts you just didn't understand, please let me know and I'm happy to revise them.
Do we already have them at our trailer?
Then what?
Starlink installed?
So this is for the town. The
Yeah.
one we have at the trailer is a different model.
I see.
And so, it's not always activated. No, we've got,
Which model is this, the mini or
this is called Gen 3. So if you would pass that around. So,
Oh, yeah.
so this is the Starlink itself. And after, we do show and tell, let people look at stuff. What I'd like to do is actually hook it up, take it outside, plug in the base station, let people connect to it and see that it works. This is not terribly hard. In some sense, once you've seen it once, you probably won't need the directions. These are the 0 words directions
IKEA direction.
from Starlink itself. There is a link in here, which of course, since it's paper, you can't click on. With the actual link to a more descriptive one. And the other thing is, if you're going to be one of the people who the town, wants to be able to set this up for the town. It's useful to have the Starlink app already on your phone, because if we don't have internet, you can't get the Starlink
Oh,
app.
thanks.
Right. You don't absolutely need the Starlink app. You can set this up without the Starlink app, but if you want to do antenna alignment or any extra diagnosis, the app is useful to have. And I believe there's also, the same link that's there is on this QR code that's here. So I'm gonna go through the pieces. There are not that many. It's not that complicated. So this is the power supply, cleverly labeled saying power supply. This is the power cord, goes into the wall. Other side goes in the power supply. Power supply goes to the access point, the Wi-Fi access point, which goes to, power supply goes into this part. And I probably should have moved this somewhere else, because this is confusing. It doesn't say power supply, but it's got the lightning bolt on it. The universal, and it's also the only port that things will fit into. Just push it.
Yeah, make it easier.
And then this is the link to the Starlink, from here to Starlink. It's got plastic caps that I probably don't need to save, but I did. And they'll probably get lost the first time we use it. The cable ends are symmetric, so it doesn't matter which one you plug into the access point and which ones you plug into Starlink. Right, below. There's one tricky part, which I'm actually going to suggest people practice at some point, which is, this is where the Ethernet port goes. And you have to push harder than you think you should. So when it's properly done, it's completely seated inside. You won't see any of this. And when you push as hard as you think you should push, you'll still see parts of it sticking out. So push harder.
Is there no release button on it? Or how do you
There
get
is
that?
no release button. You just
You
pull
pull
out.
out, yank it out.
Right.
So there are active components in it, inside this.
Yes.
Okay.
So this is a whole computer, phased array, steerable link.
So this thing doesn't move like the older one.
Correct. That's one of the cost savings, and one of the things that the Starlink app does for you is it says, okay, now point it this way or that way. So I am gonna pause now and see if anyone has any questions. Pretty simple. It is much simpler than the Gen 2 that we have at the Arc. It's somewhat simple. But the big simplicity is we changed our minds when the recommendation, and we said it's not worth saving the money. So one of the problems we have with the CERT one is, to save money, we went with the plan which isn't always active, which means you need the account password to make it active. And for the $1,000 a year, it just didn't seem worthwhile that if we need it, we won't be able to set it up and use it if the right person doesn't have the password. In theory, this should work just by plugging it in. On that sheet of paper is the Wi-Fi access point name and password. It was not designed to be mysterious or secure. So I am going to be quiet now, and
So in order to set it up, you need to be connected to the app.
no.
They'll
Don't you
optimize
need
it.
that to-
That will make it better, right, but it's optional, not required.
So to point it in the right place, you need it.
The app gives you the instructions for how to point it.
So that's the main benefit of linking to the end.
That's benefit one. The other one is if there's connectivity problems, it will give you more feedback of, okay, I see the Starlink dish, okay, finding satellites, you know. Without that, you just kind of have to blindly wait 10 minutes.
The Gen 2 had motorized, what was, in terms of directing it?
Yeah.
Yeah.
it
They
goes-
have a phased array as well, but that would just use the motor to get it close.
Yeah.
And this is just phased array is wide enough now they can just, you point it generally up.
I think they figured out they didn't desperately need it. It wasn't enough of an advantage for the complexity and cost. Because the old original, well, I know the Gen 1 one cost like $3,000 or $4,000 to Starlink. You know, and they sold them for $600. And I know the Gen 3 ones, they cost like $500 and they're selling them for $300.
Make it up in volume.
But they're actually
And
profitable.
monthly, yeah.
Yeah.
So is this weatherproof?
Yes,
You can
Well,
take it out.
proof.
Yeah, proof.
But it is, for example, heated to melt snow that goes on. In there, I'm sorry, I'll get you in just a second. This piece here just lifts out, which I don't want to do it too often.
Yeah, that's pretty well.
But it does come out, and I did it at least once, and we have a pole mount in there, so if you were gonna permanently mount it somewhere, we would-
That's what that is, okay.
pull this base off and plug in the other. But for just putting it on,
The ground.
yeah, or, you know, on a roof or on top of the ark, that kind of thing.
So basically it looks like, again, I've never seen these, so you basically consider an angle here by default.
So this, by default, it has you pointed south typically in a preferred direction.
Which equator?
And it will work even if it's misaligned, but you know, to get a couple extra tenths of dB, part of what the app does is it says, you know, do that. There's another part of the app which is almost never useful, which is looking for obstruction. So you're supposed to go like this around here and it will tell you if too much of the sky is occluded. I'm sorry, I stepped on.
I don't know, but where are you going to place this? And when are you going to place it? When is it going to be quote activated?
So it's already activated. We were going, so the internet was broken in Heritage House where the EOC is. And we were gonna set this up there, but by the time we actually got the Starlink procured, the Heritage House was closed for remodeling. So at the moment, the plan is this is gonna sit in the box somewhere. Cody hasn't told me where he's gonna put it, but I suspect in the closet in the council chambers. And if there's an emergency, this is the third independent source of internet for town hall. So the first two go through IT, this one doesn't go through IT, so we could just set it up, put it on the ground, put the access point in the EOC and people would still have access. It's also usable like when we lose power, if someone wanted to have just an independent place for Wi-Fi somewhere in town, they could take it to Burn Preserve or somewhere, wherever they want.
So this runs only from AC. You can't actually drive it from a battery or something. Unless you have an inverter.
Sort of. So that people have hacked, so if you use
Yeah.
this equipment,
Yeah.
what you said is correct.
Right.
But the people have hacked this to where they power it off of 48 volts, because this is just PoE
Okay, yeah.
for hotting it up. And so while the cable's not standard, the actual electrical connection is. And you don't have to use the access point. If you hack the cable, you can plug it into just a regular Ethernet port.
Okay.
And actually, this one here, unlike the version I have and we have at the yard, actually has two Ethernet jacks. So you can hardwire it.
Well, that's taking DC, right? So is there really no DC power to that? Yeah, there are no, I guess there are no accessories for that, because I thought people were running these, because I'm interested in one of these for solar generator kind of, emergency thing, but you need AC to do it, or?
You don't, there's so if you're
Third party.
staying with what Starlink sells you, then yes. If you're willing to go third party and hack stuff. You can look to see if it's.
Are we gonna upgrade the CERT one to Gen 3, or is there any advantage at all, or the bandwidth, is everything else the same? It's just a little easier to set this one up and then it's.
We haven't discussed it really,
Yeah.
but we could bring that up with the commissioners and see what
I
they think.
wanna make sure we have the best thing going for that.
It's only $300, so it's not a big deal. And-
I'm just really thinking about in terms of an emergency happens, ease of use can matter more than the. If there's any, I don't know if there's any functionally any
Right.
difference, if it's just.
The alternative is to get the mini. The mini is roughly a quarter the size. And people have made effectively a Pelican case with a battery
Yeah.
and the mini is actually hard mounted to the top. And you can just walk around with it.
Well, and an important piece of why we're doing this tonight is so that there are more people in town who can set one of these up. Right. One of the other concerns, of course, is that if we actually had an emergency, everything else was out. And it was just Neil and he was off doing
Yeah.
Red Cross stuff. Yeah, they'd have to find me.
Where is this kept?
So I don't know, so Cody, in Cody's office,
Okay.
and I don't know where. it's really
Town
gonna be
asset,
kept.
okay.
We'll be looking for it.
And there's one in the ARC right now.
There's one in the arc right now.
Okay. Is the ARC one, I think next time there's an ARC event, I'll ask more about it, but, is that as relatively easy to set up?
Yeah, I think so.
Except for except for we went with the data plan
Yeah,
that
so you
needs
have
to be
to,
activated.
So we'll talk about it.
you have to have Victoria's account so that you can turn it on, basically.
We got to change that.
Anyway, so it's just,
Yeah. Bring that up the next opportunity.
so I am gonna step back and I am gonna look for volunteers to go hook things up.
Does it have to be unobstructed to the sky? Like, would it work inside here?
Wouldn't work in, so needs to be not completely unobstructed. You'll just get less reliable connections, short outages, maybe less bandwidth, but indoors definitely, no,
Not gonna work.
I mean, it needs a pretty good view of the sky. The satellites are passing overhead all the time, and if that satellite that you're connected to goes behind the corner of a building or something, then you're out of luck for a short.
even leaves are enough to,
Yeah.
affect it. So
So
building
you wanna-
definitely.
You wanna find an open field where you've got
How big is
this kind of open.
How big is and you may not know this, but what's the angle of focus of the beam?
It
So
wants 160 degrees.
That's-
That's what they kind of recommend. But that's not the absolute hard limit. That's the,
I'm just wondering, because I got a lot of trees, for example, and I got house kind
Yeah.
of has trees around it. How much problem gonna have getting just sort of a subset of, I got a circle, but it's not a huge circle.
yeah, if this was your primary internet,
Mhm.
you'd want to solve that by
Yeah.
putting it on a pole on your house, on your roof, to get it as high as possible. For emergency usage, right, where anything is better than nothing.
Yeah.
Right, then you have more flexibility.
How far can you extend your interface from where you place this?
So this is 75 feet of cable, which is the default. They will sell you 150 feet. That's the longest supported length. Which is pretty far.
That's
like a
Cat 5 cable.
It is Cat 5. I mean, it's not any of the Cat 5
Yeah.
end connection standards, but electrically,
Yeah.
power wise. It's shielded Cat 6.
You know how many watts this power supply is?
It says on the back.
Oh. It might run to a little battery or something.
Yeah, actually.
So
look at
one of the
different
reasons why
connector
people get
bands.
rid of the access point and put it directly on PoE is it burns about 45 to 50 watts instead of 85 to 100.
Okay.
So
there's a big power savings by,
Is that because the power supply is inefficient or because of the Wi-Fi?
a little bit of both. Right, you're getting rid of one AC to DC transformation.
Vanilla, we're going to do a test run to see where should we.
Yes,
place it?
yes, please, by all
But
means.
No, outside.
Yeah.
So it's in a case of an emergency.
Yeah. go plug it in, make it work.
I don't wanna go in the night, I'll trip and fall.
Which is right, I mean, well, there's between.
Well, I was gonna stretch out the cable out the door and.
Yeah.
I'll go put it on the wall outside.
Let's see,
Or wherever we can find power.
Well,
where do you want?
I was gonna suggest.
I'm done.
So I think just outside, I think the wall is just what
I've been intentionally set back from the final assembly because I know too much already too.
You're dangerous.
Yeah.
But
But I can.
Bill is about to plug it into the Starlink, so does someone want to carry the cable to him?
This.
I'm just gonna put a little tension on so it goes out. Oh, you can do it, I
I
don't.
got it.
And we'll see,
Okay.
it's not going as far as I thought it would.
Okay, so let's see, where's the plug, where's the power?
It's always the hard part. There's one over here.
There's no floor.
So right in the wall here.
So is this so hard mostly because of the rubber grommets or is there something else going on there?
Hard in terms of,
The plug or unplug?
it's just that it's a waterproof connection, so
Yeah.
it's very.
Try some silicone grease on this and.
Well, what's the,
Here. That's all you get.
That's a big tree out there.
it's a Wi-Fi network.
Put this in, so it doesn't pull out.
You know, there's another power outlet out here.
Okay,
There you go.
Let out there,
Yeah.
perfect.
here. You are empowered. And I'm gonna stop the recording because we're all going outside.
How much time delay is there? These are lower orbit satellites, right?
Yeah, it's a 30